Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, we're gonna look at another question under work, energy, and power. So it says now a slide PQR. So they started here. Probably our initial starting point is P. But we'll here add an amusement park consist of curved frictionless section PQ. Before I go anywhere, where is that PQ? PQ, frictionless. I know I'm dealing with work energy and power here. I know mechanical energy at P, it is equal to, let me do this. I know that mechanical energy at P, it is equal to, let me find a suitable space. This is interesting. Mechanical energy at P, it is equal to mechanical energy at Q. Only applicable for PQ in this case. All right, let's continue. This is interesting. And the section QR, which is rough. Oh, so here there is friction. Sorry. Here there is friction, meaning that mechanical energy at Q, it is not equal to mechanical energy at R. I believe you are following. If there is friction, there is applied force. Mechanical energy cannot be conserved. But here there is no friction, there is no applied force. Our object was probably sitting on its own here and just fell. So the mechanical energy, it is conserved in that case thereof. I love physical science and physics. Now, if that's the case, let's see. Another information that's important, inclined plane of 30 degrees. All right, that one is probably given on an information to the horizontal. The starting point P, all right, here is the starting point, is 3 meters above point Q. Above point Q, not above point R. All right, above point Q, the straight section QR is 5 meters long. All right, here QR, this distance here, straight section QR, it is 5 meters. All right. Good. Now let's see. 5 meters long. Let's see. I'm happy to attempt this question. Here, remember, we can use this formula and this formula. Here, this one is not, since it is not conserved, you can only use the other two. We can also use work done by non-conservative force. All right? Yes. This is interesting. Let's without wasting any further time. Let's see. A learner with mass 50 kg, all right, starts from rest at point P. This information is very important. Rest. The velocity at P, it is equal to 0 meters per second, or you can say initial velocity. All right. Slides down from rest, starting from rest at P, slides down section PQ here first, then continues down the straight section QR. All right, QR. It's fine. All right, it's fine. I believe we are hearing that story there. Let me just remove this. Let me remove this. I'm excited. Now, what I normally say is that the examiner will ask you to state something. There are 95 chances that what the examiner is asking you to state is what you're going to use on the follow-up question, especially when you are required to calculate. Now, we are required to state the law of conservation of mechanical energy in weight. Easy 2 marks. It says now the total mechanical energy. I think this pen is too much. Mechanical energy in an isolated system is conserved. Or if you do not say is conserved, you can say remains the same. All right? Yes. This is 6.1. This is 6.1. Let's go to 6.2. I repeat. Oh, the keyword is the total mechanical energy. Total mechanical energy, where in an isolated system, what about it? Remain is conserved. Keywords. You miss any word here, they -1 or they take all the marks. Easy to marks. Now let's go to 6.2. Now that we have defined mechanical energy, there are 95 chances, 95% chance we're going to use that law to calculate the speed at Q. Now let's see. Moving from P to Q, because I cannot say Q and R because there's no way I'm going to just start from Q and now I'm going to R. No. The information starts from the beginning at P. At P it is at rest. I know my velocity at P it is 0. I've already stated that there here. So I'm gonna say, all right, I'm gonna focus at P, from P to Q, because my last information it is with regards to Q. But I know something. From P to Q, my surface is frictionless. So here mechanical energy is conserved. So it means this law is applicable. So you understand why I'm saying most of the time the examiner asks you to define something and you're gonna use that law. So you're gonna say mechanical energy at P, it is equal to mechanical energy at what? At Q. But now what is mechanical energy? Mechanical energy it is kinetic energy at P plus, all right, in this formula I prefer using this. I'll just say kinetic energy at P plus potential energy at P. It is equal to kinetic energy at Q plus potential energy at Q. Remember, U is the same as mgh, is the same as EP. All right, which is the same as mgh. So do not be confused why I'm using U. It is the same as EP. All right, if you use EP, it's still fine. Now, all right. Now let's talk. Kinetic energy at P, it is 0. Why? Kinetic energy at P, it is equal to 0. Why? Because substituting into this formula, half mvp squared, my P will be 0 and everything multiplied by 0, it is 0. We agree? Yes. So another important thing is that when I come back to my statement, P is 3 meters above point Q. If from here, let me do this. From Q going up is 3 meters. It means I can take Q as 0 reference point. I can take the height at Q as how much? As 0. Because from here to here, it is how much? It is 3. All right? Yes. So my height at Q with respect to P, it is 0. 0 meters. All right? So if it is 0 meters, it means my potential energy at Q, it is how much? It is 0. Let's come and substitute. I'm saying here I'm only left with UP, University of Pretoria, my school. Here, KP, it is 0 because the kinetic energy at P, it is 0. UQ, it is 0 because height at Q, it is 0. Now let's see what is UP. It is mgh at P. It is equal to what is kq, half mv velocity at Q squared. All right. What are we looking for in this case? We are looking for velocity at Q or speed at Q again. Speed at Q. So what is the speed at Q? We're going to say, all right, let's substitute. Mass, it is how much? 50 grams. Gravitational acceleration, height at P, it is 3 with respect to Q. It is equal to half. What is my mass? My mass is 50. What is my V? It is VQ squared. Therefore, my VQ, it is equal to, you know how to punch this one again on your calculator. Some people do not know. Let me go through this. Divide by this, divide by this. I'm going to remove. Then whatever the value that you get in here, you just have to square root it. Then you are done. I won't do this substitution. This is your math. VQ, it is equal to, let me quickly do my math. 50 times 9,8 times 3 divided by 0,5 multiplied by 50. The velocity that I get here, it is 7,668, which is 67 meters per second. But I normally say, when they ask you the speed, just say there for speed. It is, I know here it is speed because there is no direction, but please, 7.7, or rather 7.67 meters per second. All right, this is us answering the question. You can also use WNet in this case. You can also use what? WNet in this case, but it won't be necessary. Well, if you are interested in it, then you can. But yeah, if you use WNet, don't use it. Actually, don't use it. You can use it. All right. Hey, let me do this. When you use WNet, you're gonna say WNet, it is equal to change in K. Work that is done by the, it's gonna be work done by what? Here there is no force. So you agree with WNet, it is mg parallel. Why am I saying mg parallel? If this is my block, then the only force that causes to go down, it is gravity. But which gravity? That x parallel. Mg sine 30, it is equal to, what is kinetic energy? I know I'm gonna have kinetic energy at Q, which is half mv squared at Q, because half mv squared at P, it is 0. I get plus 0. Then I want you to see something. Sorry. Here I have my, oh, all right, something is missing. I'll have to say mg sine 30 multiplied by changing x cosine of 0 degrees. Why? Because my object, it is moving downwards, and gravity parallel, it is also moving downwards. So I know that it is cosine of 0 here. Cosine of 0 degrees. And cosine of 0 degrees, it is 1. So yes. So when I substitute, what is my mass? My mass, it is 50. What is my gravitational acceleration? 9,8. What is this? This is how much? Sine 30, it is half. My change in x, do we have change in x here? No, we do not have change in x. We do not have what? Change in x. Hence, it is more difficult to use what? WNet. All right. If we had this angle here, but all right, here's another thing. Ne? When you are working on a curved, like this, curved surface, avoid using WNet. WNet, do not use WNet where you have a curved surface. Why? Because we cannot calculate the actual distance from this point to this point. If you were to calculate change in x, it won't be straight. So you see there is some ambiguity there. So when you are dealing with an inclined like this, do not use WNet. I know I said it is applicable everywhere, but do not use it on a what? On a curved surface. But in this case, it is not curved. They told you it is straight section. Straight section, RQR, from QA, yes, QR here. It is straight, so we can use WNet there because we can calculate what? Change in x. I believe you now see why I used what? This mechanical conservation of mechanical energy. All right? Yes. For this one, there is no any other alternative answer. So let's go to 6.3. 6.3 says to us, draw a labeled free body diagram for the learner while he or she is on section QR. Section QR, let me remove this. I know the speed here, it is how much? 6.67 or 7.67. Yes. 7.67. This is my speed at Q. Now, I'm required to draw a free body diagram when the learner is here. Or let me see the block. I know it is not a block, but it is here. I know when it is here, there is friction. But where does friction act? Remember, my object slides downwards. So it means now, if it slides downwards, my friction will act upwards. Then here I'll still have what? mg parallel or fg parallel. Alright? Now, for 3 marks, it requires us to draw 3 forces. 6.3. Our question continues here, either way. Our question continues here. Let's see 6.3. 6.3, it is. Some people prefer doing this, saying, this is my incline. This is not straight. They say this is my incline. So when they draw their thing is there, they're going to say, the force that's always there, it is Fg. Down. Vertically downwards. Fg. Then I have the normal force acting perpendicular to my surface. It should make a 90-degree angle with my what? With my surface there. I say this is my what? My normal force. And I know there is what? Friction. My friction acts in an opposite direction because my motion moves downwards. But in this case, I can come and say, all right, I want to use this color. Despite having Fg can be broken into Fg perpendicular and what? Fg parallel. Now, when you are required to draw a free body diagram, your marks will come here. 1 mark here, 1 mark here, 1 mark here. This one that we are doing here, it is for the purpose of calculation. If you let me remove them, I'll draw them. I'll redraw them. Because unless you are required to draw it in terms of its components, Fg or any forcing components. So let me just draw it here for myself so that I can see where I'm going to be using this one. Friction, normal force, Fg perpendicular, Fg parallel. So this is me trying to see whether I'm going to be able to calculate now. But for 3 marks, you draw this. For calculations on your side or on that question paper, draw this on with your pencil. Or draw this on your question paper, not the answer sheet. All right? Now let's attempt 6.4. Oh, 6.4, here it is. It says now, a new information that we are given, the coefficient of the kinetic friction between the learner and the surface, QR, it is 0.8. Remember that this, we have friction here. Here we have friction. So we are giving them UK rather. So if you are giving them UK, it's fine. This is good. Remember, if I'm giving them UK, I can remember of this formula. Fk, it is equal to μk times normal force. This is what comes to my mind when I see μk. But let's see if I'm going to use it now. Now they say to me, calculate the magnitude of the kinetic friction force acting on the learner when the learner is on section QR. Now, remember I said when I'm giving μk, I think of this formula. Now they want this. I have this. Do I have the normal force? Yes, I have the normal force because I know what? I know my Fg perpendicular. So I have my normal force. All right? Which in this case, it is equal to Fg perpendicular. And when I attempt to answer this question, I'm going to say 6.4. Fk, it is going to be μk multiplied by normal force. But in this case, what is my normal force? My normal force it is equal to Fg perpendicular. But what is my Fg perpendicular? My Fg perpendicular it is mg cosine of my angle. All right. Now let's substitute Fk. It is equal to what is mu k? Mu k it is 0.08. What is my mass? My mass in this case I was given as 50. Mass of the learner 50. Gravitational acceleration 9.8. Cosine of which angle am I talking about? This angle here, 30 degrees. All right? Yes. Cosine of 30 degrees. Then let's punch this to on our calculator. I prefer doing this. This is still FK. Yo, I know. Where is my calculator first? 0.08 multiply by 50 multiply by 9.8 multiply by root 3 divided by 2, which is cos 30 in this case. The answer that I'm getting, it is 33.95, which is 948, but 95 what? Newtons. Remember they said calculate the magnitude. If they say calculate the magnitude, you do not need to include the direction or it is acting upwards. So we'll just say 33.95. If let me just recalculate my value. It is very easy to make mistakes. Yes, 33.95, it is the correct answer. So now 6.5 says use energy principle to calculate the speed of the learner at R for 5 marks. But work energy and power is so very nice. I do not want to say easy because as people we do not take things or rather we do not grasp information the same, and sometimes it does happen that our teachers do not actually teach us in the way that we want to learn maybe, hence we sometimes rely on YouTube. I also where this English, I also watched YouTube very much. It was very vital. It was very vital. All right, now use energy principles. So the energy principles that are applicable, it is this formula or this formula in this case, but not this formula. This formula, it is not applicable because it is not conserved. All right, let me remove this. Remove. So I can only use these two formulas. Let me see if I have enough time to do the both of them. Yeah, I don't think I'll have enough time, but let's try. Let's see. 6.5 fast. I want to use this one. I've been using that one a lot. But let's see. When I talk of changing H, remember I'm going to need, if I'm talking from Q to R, I'm going to need this H here. And this H is going to be what? This H is going to be what? If this is my change in X, my hypotenuse, and this is my right angle triangle, is going to be sine 30. It is equal to opposite, which is H, divided by hypotenuse, which is change in X, which is 5. Then my H is going to be 5 sine 30. Please take it as it is. Take it as 5 sine 30 so that the examiner can see where you take it. Because when you substitute 2.5, it's going to be a equation where does it come from. All right. So we agree that the height final here, it is 0, or the height at R, it is 0 here. So let's try to manipulate this. Work done by non-conservative force. I look at my free body diagram. It will only be work done by what? By friction. Because why? Friction, it is what? Friction, it is a non-conservative force. So it is the only force that will be included. But some will say, how? But you said Fg parallel, also X parallel, and all forces acting parallel do work. But yes, in this case, on this formula of work done by non-conservative force, Fg parallel, it's not a non-conservative force rather. It is a conservative force. So I'm going to say work done by friction is equal to half mv squared. Let me see any information whether when it reaches R. So all right, it's going to be half mv squared at R, which is the final, minus half mv squared initial, which is q, it started at q, plus mgh at r, which is the final, minus mghq, which is the initial. But now we said height at r, it is 0. Height at r, it is 0 here. Why? Because there is no height here. It is at the ground. So I'm going to substitute this as 0. So I'll ignore this one when I substitute. So what is work done by friction is going to be, friction changing x changing x cosine of my angle, which it is equal to a half mv squared at r minus half mv squared at q minus mgh at q. Look, I'm ignoring mgh at r because its height there, it is 0. So it's a matter of just substituting. Let's just do that. What is my friction? I just calculated as 33.95. My change in x, it is 5 meters. Cosine of, remember friction always x opposing the motion, 180. It is equal to half. What is my mass? 50. Remember, I'm looking at the velocity. I want the velocity at r. Okay? Minus half my mass 50. Velocity at q is what we calculated in 6.2 rather, which is 7.67. So let's substitute 7.67 squared minus my mass 50, gravitational acceleration 9.8. The height at q, remember it is what? 5 sine 30. Sine 30 degrees there. Please let me do this. I'm saying it's going to be 50 9.8. I'll try to squeeze that. 5 sine 30. Sine 30 there. All right. Then now it's a matter of us doing our mathematical gymnastics, and I think this is your algebra. So I'll just find the value here using my calculator. Fast. It's gonna be. Let me do this. Square root of. Where's my square root? Square root of what? 33.95 multiply by 5 multiply by cosine of 180 plus, I take this one to the other side. It's going to be plus 0.5, which is half, times 50 times 7.67 all squared. I also take this to the other side. It's going to be plus what? Plus 50 multiplied by 9.8 multiplied by 5 sine 30, which is half. Half in this case. Therefore, I will divide everything by this value here, by half. So I'm still working under my square root, or you can do however your algebra there. But your final answer should be the velocity at r as 10.05 meters per second. Therefore, I conclude therefore speed, it is equal to 10.05 meters per second thereof. All right. Yes. That's it. Remember now, it is my value, it is very right, correct, because now my velocity here, it is 7.67, here it is 10.05. So it shows us as my object moves down, its velocity increases. Okay. So thank you very much, folks, for watching today's video. Until we meet again, thank you.